What is going on, guys? It's Scott with Neverhedge back for another Cryptozombies tutorial. Hopefully you made it through lesson 1 without killing yourself. I barely did myself. We're going to stumble our way through the next one together, guys. We are on to lesson 2. So, let's go on to lesson 2 here. Zombies attack their victims. Impressive human, you're a better coder than I thought. Lesson 2 will teach you how to multiply your zombie army by feeding on other life forms. In this lesson, we're going to cover some more advanced Solidity concepts, so it's highly recommended that you complete lesson 1 before starting. Oh boy. Buckle up. Alright, lesson 2, chapter 1, lesson 2 overview. In lesson 1, we created a function that takes a name, use it to generate a random zombie, and adds that zombie to our app's zombie database on the blockchain. In lesson 2, we're going to make our app more game-like. We're going to make it multiplayer, and we'll also be adding a more fun way to create zombies instead of just generating them randomly. How will we create new zombies, you might ask? By having our zombies feed on other life forms. That's interesting. When a zombie feeds, it infects a host with a virus. The virus then turns the host into a new zombie that joins your army. The new zombie's DNA will be calculated from the previous zombie's DNA and the host DNA. So this is like NFT breeding. And what do our zombies like to feed on most? To find that out, you'll have to complete lesson 2. Let's see. This is a simple demo of the feeding to the right. Click on a human to see what happens when your zombie feeds. Old no names DNA. Okay. Let's try another combination here. Bank, bank. Nice. And also nice. Cool. All right. Moving on. All right. Mapping and addresses. Okay. To make our game multiplayer by giving... Let's make our game multiplayer by giving the zombies in our database an owner. To do this, we'll need 2 new data types, mapping and an address. An address on the Ethereum blockchain is made up of accounts, which you can think of like bank accounts. An account has a balance of Ether, and you can send and receive either payments to other accounts, just like your bank account can transfer money to other bank accounts. Each bank account has an address. Yeah, okay, we know about Ethereum wallets and stuff like that. All right. Let's work on mappings here. In lesson 1, we looked at structs and arrays. Mappings are another way of organized data in Solidity. Defining a mapping looks like this. Mapping... parentheses, address, arrow, unit, parentheses, public, account balance, or could be used to store. Look up usernames based on user ID. So mapping, unit, string, user ID name. A mapping is essentially a key value store for storing and looking up data. In the first example, the key is an address and the value is a unit. In the second example, the key is a unit and the value is a string. All right, we're going to put this to the test here, guys. Oh, I'm already not feeling good about this. To store zombie ownership, we're going to use 2 mappings, one that keeps track of the address that owns a zombie, and the other keeps track of how many zombies the owner has. Create a mapping called zombie to owner. The key will be a uint. And the value in address. And let's make the mapping public. And 2, create a mapping called owner zombie count, where the key is an address and the value is a uint. Remember those semicolons. All right, so my first guess at this is mapping address to uint public and zombie to owner instead of account balance. And then we're going to go mapping think we're going to do the same thing and just do owner zombie count instead of zombie to owner. Equals arrow uint this one we're not going to put any public or private designation because it's not telling us to, like the other one. And this one is going to be, hang on, this one is going to be owner zombie count. All right, let's see. Nope. Oh, hang on. That's an easy fuck up. Still no. I forgot the fucking semicolon. And I forgot the capital C. Little things, guys. I think I gotta switch these around. Maybe. Yes. Got it. Using the old ticker there. All right. Now, message sender. Now that we have our mappings to keep track of who owns a zombie, we're going to want to update the create zombie method to use them. In order to do this, we need to use something called the message.sender. In Solidity, there are certain global variables that are available to all functions. One of these is the message sender, which refers to the address of the person or smart contract who called the current function. Here's an example of using the message.sender and updating a mapping. Okay. Here it is. Here's that gobbledygook. Okay, in this trivial example, anyone could call set my number and store a uint in our contract, which would be tied to their address. When they called what is my number, they would be returned the uint that they stored. Okay, using message.sender gives you the security of the Ethereum blockchain. The only way someone can modify someone else's data would be to steal the private key associated with their Ethereum address. Okay. So let's take a crack at it. Okay, so let's update our create zombie method from lesson 1 to assign ownership of the zombie to whoever called the function. First, after we get back the new zombie's ID, let's update our zombie owner mapping to store the message.sender under that ID. Second, let's increase the zombie owner count for this message.sender. In Solidity, you can increase a uint with ++, just like JavaScript. Final answer for this chapter should be 2 lines of code. Okay, this one was a little trickier. Had to look up the answer. instead of spending 20 minutes trial and erroring this. So what do we got here? Zombie to owner. I was right on that first. So we gotta go zombie to owner. ID. I was fairly close on the first one. Equals owner zombie count all right, well, had the answer in front of me, still couldn't spell it right. Still can't spell it right. All right. Failed that test. Awesome. All right, now we got to set some requirements. So in lesson 1, we made it so that users can create new zombies by calling create random zombie function and entering a name. However, if users could keep calling this function to create unlimited zombies in their army, the game would be very fun. Let's make it so each player can only call this function once. That way, new players will call it when they first start the game in order to create the initial zombie in their army. How can we make this so this function can only be called once per player? For that, we use require. Require makes it so that the function will throw an error and stop executing if the condition is not true. This is an example of that. Okay. If you call this function with say hi to Vitalik, there it is. It will return hi. If you call it with any other input, it will return an error and not execute. So, require is quite useful for verifying certain conditions that must be true before running a function. Okay, that seems useful. Now, in our zombie game, we don't want the user to be able to create unlimited zombies in their army by repeatedly calling create random zombie. It would make the game not very fun if there were unlimited zombies out there. Let's use require to make this function, make it so this function only gets executed one time per player when they create their first zombie. Let's put a require statement at the beginning of create random zombie. The function should check to make sure owner zombie count is equal to 0 and throw an error otherwise. Okay. So we have to put this first. Owner zombie count, message sender. Let's see. Okay, hang on. Let's go require. Okay. Parenthesis. Okay. No. So my first guess was require owner zombie count message sender equals 0. Do I need 2 equals? Oh, you gotta be kidding me. So I was pretty much right. I just forgot a little space here. And, of course, the fucking semicolon. So this is what I had. And I was pretty much, my first attempt was pretty much spot on. Just little things here. Forgot these little spaces. Okay. So close. I'm about 97% of the way there. It's just these little things, which is why the Cryptozombies is, I think it's probably one of the best ways to learn. All right, here we go. Chapter 5, Inheritance. This is already way quicker than Lesson 1. This probably won't even take me 3 hours this time. All right, Chapter 5, Inheritance. Our game code is getting quite long. Rather than making one extremely long contract, sometimes it makes sense to split your code logic across multiple contracts to organize the code. One feature of Solidity that makes this more manageable is contract inheritance. Okay. Baby Doge inherits from Doge. That means if you compile and deploy Baby Doge, it will have access to both catchphrases and another catchphrase. Okay. Baby Doge. Okay. And any other public functions that we may define on Doge. This can be used for logical inheritance, such as with a subclass. A cat is an animal, but it can also be used to simplify for organizing your code by grouping similar logic together into different contracts. Okay. Might be able to do this. In the next chapters, we're going to be implementing the functionality for our zombies to feed and multiply. Let's put this logic into our own contract that inherits all methods from the zombie factory. Let's make a contract called zombie feeding below zombie factory. This contract should inherit from our zombie factory contract. So let's start here. This contract's not that long. I don't know what they're complaining about. Okay, so let's give it a try. Okay, this is possibly right. So here, contract zombie feeding is zombie factory. So copying the baby Doge is Doge. This is the subsequent contract that we're going to create, and that inherits from the zombie factory. Let's see. Yes. All right, we're good. We're doing it, guys. We're learning some things here. So, we've got to use the import to read the contents of the other file. All right. Import. I'm going to put the quotations // zombie factory.sol. And what do we not want to forget? Fucking semicolons. We're zooming today. All right. In Solidity, all right, so Chapter 7, storage versus memory. In Solidity, there are two locations you can store variables in: storage and in memory. Storage refers to variables stored permanently on the blockchain. Memory variables are temporary and erased between external function calls to your contract. Think of it like your computer's hard disk versus RAM. Most of the time, you don't need to use keywords because Solidity handles them by default. State the variables. Variables are declared outside of functions, are by default storage and written permanently to the blockchain, while variables declared inside functions are memory and will disappear when the function call ends. However, there are times when you do need to use these keywords, namely when dealing with structs and arrays. Don't worry if you don't fully understand when to use which one yet. Thank God. Throughout this tutorial, we'll tell you when to use storage and when to use memory, and the Solidity compiler will also give you warnings to let you know when you should be using one of these two keywords. For now, it's enough to understand that there are cases when you'll need to use explicitly declare storage or memory. All right, let's do it. When a zombie feeds on some other life form, its DNA will combine with the other life form's DNA to create a new zombie. Create a function called feed and multiply with two parameters: zombie ID, a uint, and target DNA, also a uint. The function should be public. Do I remember how to do functions? We don't want to let someone else feed on our zombie, so first, let's make sure we own this zombie. Add a require statement to verify that message.sender is equal to the zombie's owner. Similar how we did the create random zombie function. We're going to need to get the zombie's DNA. So the next thing our function should do is declare a local zombie named myZombie, which would be a storage pointer. Set this variable equal to the index zombie ID in our zombies array. Good God. All right, we're going to set ourselves up for greatness here. Okay, this I remember. Well, this is great. I forget how to do the message.sender, so I'm going to check the answer quick. Admit defeat. Okay, close on the first line. And we got require, and I never would have got this. So, good thing I looked it up. What did we almost forget? Yet another semicolon. All right, stumbled our way through that one. All right, chapter 8. Let's finish writing the feed and multiply function. The formula for calculating the new zombie's DNA is simple. The average between the feeding zombie's DNA and the target's DNA. This is actually very, very useful because I was researching the D-Race game yesterday and was wondering how to make NFTs that breed, because that is one of their main selling points, is you can breed the horses in D-Race and resell them. So this is answering that question and then some. Okay. This is pretty much exactly how they do it. So, for example, we got function test DNA splicing public uint zombie DNA 2222, uint target DNA 4444, uint new zombies DNA equals zombie DNA plus target DNA divided by 2. This will be equal to 3233. So first we need to make sure that our target DNA isn't longer than 16 digits. We can set the new target DNA equal to target DNA % of DNA modulus. That will only take the last 16 digits. Next, our function should declare a uint named new DNA and set it equal to the average of my zombie's DNA and the target DNA as in the example above. You can access the properties of myzombie using the myzombie.name and myzombie.dna. Once we have the new DNA, let's call create zombie. You can look at the zombiefactory.sol tab if you... Oh, I forgot I had this one. That would have saved me some trouble in the last module, or the last chapter. Note that it requires a name, so let's set our new zombie's name to no name for now. We can write a function to change the zombie's name later. All right, let's see. All right, so we're not writing the function yet. We're just doing the target DNA and all that, I think. Let's see. I think we actually have to create a function here. So let's do that. We actually already created the function in the previous chapter, so we got to add to the function. That's what we're doing here. All right, this is what I got here. So target DNA equals target DNA % DNA modulus uint new DNA equals myzombie.dna plus target DNA over 2. I think that's what they want. Create new zombie, no name, new DNA. Let's see what I did wrong here. Maybe we got a space. I guess that's what it looks like there. Okay, there were spaces. Looks like I missed a couple capitals. Capital Z, capital Z, and that might, do we need a semicolon? Let's put one here just in case. No, okay. Maybe no semicolon. No name, got that. Create zombie. Semicolon here, maybe. No. Maybe 2 semicolons. No. All right. Show me the fucking answer. Oh. All right. Couple things I missed here. This, missed the old under skeezies on the target's DNA, missed fucking semicolon. And let's try it again. Boom. Okay. Just a couple little things. Pretty close again. All right. Let's see what they want us to do next. More on function Visibility. The code in our previous lesson has a mistake. If you try compiling it, the computer will throw an error. The issue is we tried calling the create zombie function from within the zombie feeding, but the create zombie is a private function inside the zombie factory. This means none of the contracts that inherit from the zombie factory can access it. In addition to public and private, Solidity has two more types of visibility functions, internal and external. Internal is the same as private, except that it's also accessible to contracts that inherit from this contract. Sounds exactly like what we want here. External is similar to public, except that these functions can only be called outside the contract, which means they cannot be called by other functions inside of the contract. Change create zombies from private to internal. Okay. Internal. Do we want... There we go. Boom. What do zombies eat? CryptoKitties. That's pretty funny. All right. What do zombies eat? It's time to feed our zombies. What do zombies like to eat most? CryptoKitties. In order to do this, we'll need to read the kitty DNA from the CryptoKitties smart contract. We can do this because CryptoKitties data is stored openly on the blockchain. Isn't the blockchain cool? Yes, it is. So I'm trying to learn about it. Don't worry, the game isn't actually going to hurt anyone's CryptoKitty. We're only reading the CryptoKitties data. We're not actually able to delete it. Interacting with other contracts for our contract to talk to another contract on the blockchain that we don't own. First, we need to define an interface. Let's look at a simple example. Say that there was a contract on the blockchain that looked like this. This would be a simple contract where anyone could store their lucky number and it will be associated with their Ethereum address. Then anyone else could look up that person's lucky number using their address. That's pretty interesting. Now let's say we had an external contract that wanted to read the data in the contract using the getNum function. First, we'd have to define an interface on the lucky number contract. Show. Okay. We got to create an interface here. So what we got to do, put it to the test. We looked up the CryptoKitties source code for us and found a function called getKitty that returns all the kitty's data, including its genes, which is what our zombie game needs to form a new zombie. The function looks like this. Okay. This is the function. It returns a bunch of different values. If you're coming from a programming language like JavaScript, this is different. In Solidity, you can return more than one value from a function. Now that we know what this function looks like, we can use it to create an interface. So, we got to define an interface called kitty interface. This looks like looks just like creating a new contract. We use the contract keyword inside the interface. Define the function getKitty, which should be a copy and paste of the function above. with a semicolon after the return statement instead of everything inside the curly brackets. Okay. 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 All right, so we made our interface. Get kitty or kitty interface, and we got some curly brackets here, and then we got to paste. I believe we got to do this one. Just paste this line. In here, and then semicolon, and we could do that. Okay. I think I need all this shit in there too. All right, let me redo this. Nay. Oh. Do I need a semicolon here? Yes! Semicolons strike again. That's hilarious. All right, we figured that out. Only hour and 15. We're zooming right along. All right. Continuing our previous example with the number interface, once we've defined the interface as contract number interface, function, get num, address, my address, we can use it in a contract as follows. Here's our CryptoKitty address. Okay. In this way, your contract can interact with any other contract on the Ethereum blockchain as long as they expose the functions as public or external. Let's set up our contract to read from the CryptoKitties smart contract. We save the address of the CryptoKitties contract in the code for us under a variable named CK address. Okay, there we go. In the next line, create a Kitty interface named Kitty contract and initialize it with the CK address just like we did in the number contract above. Okay. Okay. All right. I think this is maybe what they want. Okay. Fucked up a couple things. And do I need a semicolon Let's see there. CK, this looks like it's got to be capitalized. And I screw up the C here. Yes. Zooming today. Okay. Handling multiple return values. This getKitty function is the first example we've seen that returns multiple values. Let's look at how to handle them. Function, multiple returns. Here. You can read that. Now, let's put it to the test. Time to interact with the CryptoKitties contract. Let's make a function that gets the kitty genes from the contract. Make a function called feedOnKitty. It will take two uint parameters, zombie ID and kitty ID. Should be a public function. The function should first declare a uint named kitty DNA. Oh, God. All right. Uint and uint256 are the same thing. The function should then call a kitty contract.getKitty function with the kitty ID and store genes in kitty DNA. Remember that getKitty returns a ton of variables, 10 to be exact. But all we care about is the last one, genes. Count your commas carefully. Oh, fuck. Finally, the function should call feed and multiply and pass both zombie ID and kitty ID. Holy shit. This is hard. Okay. So I think we can model it pretty similarly to this one here, this last function that we made, but we just got to put the right things in there. All right, so this is our function here, function feedOnKitty uint zombie ID and kitty ID. We made that a public function and we declared our uint kitty DNA, and then we got to count all these fucking commas up here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we got 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the last one is kitty DNA. And the equals kitty contract dot get kitty, kitty ID. Feed and multiply the zombie and the kitty. So the kitty DNA is in the kitty genes. And I probably fucked something up. Nope. Took me a couple minutes, but all right. Bonus kitty genes. So the function logic is now complete, but let's add in one bonus feature. Let's make it so zombies made from kitties have some unique feature that shows they're cat zombies. To do this, we can add some special kitty code into the zombie's DNA. If you recall from lesson 1, we're currently only using the first 12 digits of our 16-digit DNA to determine the zombie's appearance. So let's let the last two unused digits to handle special characteristics. We'll say that cat zombies have 99 as their last two digits of DNA, since cats have 9 lives. So in our code, if we say we'll say if a zombie comes from a cat, then set the last two digits to 99. Huh. Okay. If statements. I think we did some of those on here. Probably not. Whatever. Did we? Who the hell knows? Okay. If statements in Solidity look just like JavaScript. Function, eat BLT, string memory, sandwich, public, if cacac equals cacac, encode package, if sandwich equals BLT, comma, eat. Okay. Let's throw some cat genes into the zombie. So first, let's change the function definition for feed and multiply so it takes a third argument, a string named species, which we'll store in memory. Oh, God. There's a lot of purple in here. Next, after we calculate the new zombie's DNA, let's add an if statement comparing the cacac256 hashes of species and string kitty. We can't directly pass strings to cacac256. Instead, we'll pass ABI encoded packed species as an argument on the left side, and ABI encoded packed kitty as an argument on the right side. So this is the left side, this is the right side. Inside the if statement, we want to replace the last two digits of DNA with 99. So one way to do that is using the logic new DNA equals new DNA minus new DNA percent 100 plus 99. So for an explanation of this, we have assume new DNA is 334455, then the new DNA percent 100 is 55. So new DNA minus new DNA percent 100 is 334400. Finally, add 99 to get 334499. Okay. That makes sense. Lastly, we'll need to change the function call inside feed on kitty. When it calls feed and multiply, add the parameter kitty to the end. Okay. Okay. All right, so this is what I got here. And I think for a lot of these answers, you can, or at least for this one, I think you can copy a lot of the stuff from here and here. So I modified the function by adding a third variable here, or a third argument. So I just kept this exactly the same, just added comma, string memory, species, because we want to remember the string for species for a third argument. Now, I guess I can delete this. Okay. Now, this is the if statement that I used. I basically copied this whole thing and just changed sandwich to species equals kitty, and then copied this last bit, new DNA equals DNA minus new DNA percent 100 plus 99, like that. And then I probably should delete this last bit. All right, let's see. No. Where's that? Okay. So I got to modify the function call here. Oh, I missed this entire part. Okay. Okay. All right, it's saying that just adding this is incorrect. I gotta get them to show me the answer because they're not giving me any feedback. Okay. So forgot to put a brackety bracket. That was fucking it. I forgot a little brackety bracket. Jesus Christ. All right, wrapping it up here. We're coming to the end. It's only been hour 41. Jesus Christ. All right, not any closer. Well, it might be. All right. JavaScript implementation. So we're just going to do that. Okay, we got the idea. Boom, done. Actually, we did finish that quicker. Hour 41. This was a little bit easier than the first one because we already have a little bit of knowledge already. But that is all we got for today, guys. We did another one. Good job, all of us. Hopefully you've been following along with me and maybe picked up a few things, learned from my mistakes. So that is pretty much all I got for you today, guys. So as always, please make sure you are subscribed to the channel for more lessons on learning Solidity. And thank you guys so much for watching this far, and I will see you in the next video, guys.